Hello friends, here the operating system class. In this class we will learn process types of process. In previous class we have seen multi-threading. Now here we will see process type. Here the two types of process, independent process and cooperative process. Communicating process and coordinated is also called cooperating, coordinate and communicating process. Here the independent process. Which process we call independent process? The process which do not communicate with other process is called independent process. Means that if there is a process and they don't make the communication with other process, with other process, that process we called independent process. They are not dependent on any other process. It's an independent. Then cooperative and communicating process. The cooperative processes are the communication with others. The cooperative process are that process which make the communication with other process. Means that if the process make communication with other process for some sharing the variables and some other features, then this type of process is called cooperative process, and they are dependent on another process. So the need of synchronization. Here we see the need of synchronization when their process is communicating with other process. So when there's two or more processes are communicating with each other, and they must execute in such a way the final results generated should be as per the expectation. Means that if there is a 2 or 3 or 4 or many processes, and if they are independent, these are cooperative or dependent on each other, then we should need to synchronization to synchronize the process. Means that this process and this process will execute, so that the result will comes as per our expectation. Okay. Now the problems with synchronization. What the problems will come with a synchronization? The first one is inconsistency, loss of data and deadlock. These are the problems comes when we don't use synchronization. If we don't use synchronization, these are the three problems which will occur. The problem is inconsistency. Means that when there is a 4 problem, let's say example, there is a 4 process, P1, P2, P3, P4, 4 processes. So need of synchronization is here that when the process 1 will execute, when process 2, when process 3, when process 4 will take the execution of that program. Inconsistency आएगी. Loss of data means that if there is any share variable, let's example take any share example. If the P1 process take the share variable and take some manipulation and change it, when another programs comes and take the value of that shared variable, that value already changed. And if we take that this shared variable, take the data of shared variable and delete the dead data. If the another P3 comes and try to take the data of shared variable, but data was deleted by the P2. So loss of data because of a synchronization, because there is not proper synchronization. There must be deletion of the variable at the last process, it done by the last process, but that last process comes at a second position or first position or before its occurrence and delete the data. So another process for the upcoming process will not access that data if we delete it by the program. So there is loss of data. Deadlock means the deadlock happens if the process is try to access any resource and another process is holding that resource and try to access another resource. So the deadlock condition we will see the deadlock in details in upcoming video. So here the process, here the full process of code, like there is some instruction of code in a process. These instructions are independent. These instructions do not need of any help of another program to execute them. They are independent, and independent execution is done by the CPU. Okay, CPU execute these programs independently. Let's check here. There is some instruction of code in which code need the communication with other process. These instruction execution will need synchronization. Here means that here is some code which needs to communicate with another process, and if there is any shared variable is here, present is here, anything it so this section where the communication of another process happens is called critical section. Here the communication happens, communication with share variable, messaging, anything. Here when the program execution need to be a interference of another process, when there is a need of interference of another process, this area we call critical section. And in this critical section we need to synchronize it. Means if there is two or three processes are executing these code, so we need a synchronization when when P1 will execute this code, when P2 will execute, when P3 will execute. This is a shared code. This code is shared code, and execution is done by synchronization of the process. So here we define the synchronization when P1 will execute this code, when P2 will execute this code, when P3, because these are the shared code of instruction are shared among the two or three or more process. Okay, now and after this, here this is also an independent code. Here no need of interference of other process, so this can be executed by the CPU independent. No need of any other process interference. But this part of code need of communication with other processes, so need of synchronization, and this part we call critical section. By critical section, because here we need synchronization. Let's take an example of synchronization. Okay, the definition of critical section: the critical section of a code segment where shared variables can be accessed. In critical section, there is a program in which shared variables are defined and which can be accessed by the many programs. Okay, now the terms called race condition. What is race condition? A race condition is a undesirable situation. Race condition is a situation where occur when the final result of the concurrent process depend on the sequence in which the process completes the time their execution. This is the definition of the race condition. Here we see the race condition comes. A race condition is a situation when the final result of the execution, the final result of the sequence, final result of the execution is depend on the sequence of the process. Depend on the sequence of the process execution. Okay, so here we take a simple example. Let's take there is a program 1 and process 2. Here the process 1 and process 2. Okay, here so first there is a P1 process P1 and process P2. P1 process execute these 3 lines of code, and the P2 will execute these 3 lines of codes. First we do the chance to P1. First we first we provide the chance to the P1. So when the P1 will execute first line of code, R1 is equal to X. Here we take X is equal to 5. Okay, here we take X is equal to 5 initially. First the X is R1 is equal to X is equal to 5. So R1 is equal to 5. Okay, now here the preemption happens. Preemption of the code is happened. Now the P2 process will come on CPU for execution. When the CPU comes, when process P2 comes for execution, then R2 is equal to X and X is equal to 5. Okay, now again the preemption happened. Now again P1 process will come. When again P1 process will come, then second line of code execution happens. Second line of code says that R1 plus R2. R1 is equal to 5. By the previous value, R1 is the 5 and plus 2 is equal to 7. So R1 is equal to 7. Now here again preemption happens. Now process P2 will execute now. So the R2 value is 5 plus 3, 8. The R2 value is 8. Then again preemption happens. Then process P1 execute X is equal to R1. So R1 is equal to क्या? R1 is equal to is 7 by the previous value for P1. For P1 R1 is equal to 7. Now here again preemption happens, or process completed that preemption happens. Now for P2 last line of execution, X is equal to R2. The final result will come here 8. 8 is the final value of the X. Okay, here the 8 is the final value of X. And if they execute P1, P2, P1, P2 means if we get a chance P1 to execute first. In second manner, we can run the process in this manner. First we get the chance to P2, then P1, then P2, then P1, then P2, then P1. So when we get first chance to P2, then X is equal to 5, then preemption happened. For P1, X is equal to 5, same things, then P2, then P1, then at last P2 get the process X is equal to R2 8, then P1 X is equal to R1, the value becomes 7. Now here we see that when we change the sequence of the process execution, the value of final outcomes will vary. Okay, when we get the chance P1 to run first, execute first, the value become 8. When we get a chance P2, the resulted value will come 7. Means that here the sequence of process execution is necessary to get the expected result. Okay, to get the expected result, here the need of synchronization or need of sequence, proper sequence is necessary to get the expected result. Because if we don't provide a in which sequence the process will execute, the resulted outcomes will vary. So this is a race condition where the need of sequence of the process execution is necessary to get the expected result. Otherwise the process will happen and the result will comes random. Okay, now here are some questions. You can try it by yourself. Let's say one more example. Okay, here another example. Here the shared variable called X is equal to 10, then the process P1 which is X is equal to X divided by 2, and process P2 which will do X plus, which will add plus 4 in X. Now these two processes can be executed in different manners. First case, if we do the chance to the P1, the P1 run first completely, then P2. Okay, so what will the outcomes? Here the when P1 execute first, so it divide X by 2, so there is 5. then P2 run first, then P2 run second, then the value of x is now become 5. The 5 plus 4 result will come 9. Okay, now in case 2, when P2 will completely first, then P1. Here the first P2 will come execute first, then P1. When P2 will execute, so x is equal to 10. 10 plus 4, 14. 14. Now the P1 will execute. For 14, x become 14. 14 by 2, it's 7. So x is equal to 7. In case 3, when both read x together, here the value of P1 x, the value of x is read by both processes simultaneously, but the P1 completes its execution first. P1 completes its execution at last. The P1 will finish the execution of the program at last. So that the changes done by the changes done by the P1 will consider as a final result, because here in both cases, here the P1 will read x is equal to 10, P2 will read x is equal to 10. In both cases, when x is x plus 4, 14, and x divided by 4 is divided by 2, 5. Okay. So here when the P2 here together and P1 finish last, here the P2 will finish 15 and P2 will give result 14 and P1 will give result 5. But when P2 complete first, it will change the value of x to 14, and P1 and then after that, after changing the value of x by the P2, the P1 execution will completed, and now P1 will change the value of x, so that in case of P1 the value of x is 5, so will it change the value of x is equal to 5. It change the value of x to 5. Now here it's wrong. Okay, it's not 7, it's 5. Okay, here the value of x become 5. For this condition, x value of x become 5. Okay, now in case 4, when both read x together and P2 finish last, P2 read last, means that here when P1 and P2 will read the value of x together, for P1 x become 5, and for P2 changes after the execution. After execution, the value of x become 14. Here the after execution of x, so P1, the value become 5. But in first P1 execution complete first, so that the value of x is overridden by P1, so the value of x become 5 now. After that, P2 will change the value of shared variable. So for in case of P2, the value of shared variable change to 14. So the final value of x is 14, because P2 changed the last value, because in last the P2 changed the value of x, because P2 is last, P2 finished last, so the change is done by P2 in last. So the changes, so the final value of x is 14, so the result will become 14. So here there is a 7 value of x come, 9, 7, 5 and 14. Here the 4 value of x will come here, 7, 9, 7, 5 or 14, because due to the race condition. If we don't provide the condition, when which process will execute, the process will execute. Our answer final result may be vary. It become 9, it become 7, it become 5, it become 14. Okay, so we need to be a provider proper synchronization. So when this process will execute when this. If we expected the result, that accepted result will, if we expect the result will come 9 or your result will become 7 because you haven't provided sequence of the execution. We haven't provided the sequence of execution, so our result becomes 7, but you are expecting the result become 9. Why? So here the need of the synchronization happens in case of race condition. Okay, to avoid the race condition, we need to synchronize the process. So here a requirement for the solution of critical section. This topic we cover in next video because the video become already in 21 minutes. Okay, so we will start this topic in next video. Thank you.